Alright, so I'm going to do a lesson real quick on projectiles, and what a projectile is basically, it's a glorified word problem, such that they usually use things like v naught, which talks about the initial velocity, which is found by the coefficient of t, and it's how high is an object after t seconds. And they're not talking about trajectory per se, because we don't know what's going to happen. We don't know if the person's throwing it straight up and down, like my picture indicates, or if it's going out. In any event, we do know one thing. The height depends on the time. And if the time is 0, we can figure out how high um, the bottle started, or I'm going to say we're throwing a bottle into the water, and we can find out how high it starts off. So if I plug in h of 0, I get plus 120 times 0 plus 80. Everything goes away except for the 80 at the end. So I'm starting at 80 feet. So sometimes people say, well, how long will it take before the bottle gets um, to the maximum height? So how long until the bottle, or the object I should say, gets to max height? Well, in order to find that, you have to realize that we're working with a quadratic function, and quadratics look like that when their leading coefficient is negative. And so it will have a max height, and that's found by using the formula x equals negative b over 2a. Well, no refresher. This is my a. This, and notice I'm keeping my signs, it's my b, and this is my c. So I'm going to say, well, I'm not going to say x because we're not using x, we're using t. T equals negative b over 2a. So my time will be negative 120 over negative 32. Let's see, 120 divided by 4 would be 30. 32 divided by 4 would be 8. I'm going to divide this, so I get 15 over 4, which equals 3 3/4. So 3.75 seconds is how long it's going to take to get to the max height. Well, that's great, but how high is it at the max height? Well, now I'm going to plug in h of 3.75, and I'm going to get negative 16 times 3.75 squared plus 120 times 3.75 plus the initial height of 80, and that gives me, let's see, I'm going to type this into my calculator real quick. 3.75 squared plus 120 times 3.75 plus 80, and that gives me 305 feet. All right. Now there is one other thing that we look for, and that's when is it going to hit ground level, or in my case, the ocean, with my big fish in here. Arr. All right. Well, if you're thinking about that, then what we're really thinking is, where are the roots? So I'm going to set this equation equal to 0. And if you think about this logically, it's just a quadratic. So we're going to do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to plug it into the quadratic equation. And that's, if you hear some giggling behind, it's my very mature wife laughing at me. I like to call her biggest fan ever. So I'm going to erase all of this, and I'm going to do some quadratic work. And once again, we know what those values are because we had them up here. So it's going to be, technically, it's going to be t equals. So it's going to be t equals negative 120 plus or minus the square root of 120 squared minus 4 times negative 16 times 80 all over 2 times negative 16. Well, when you do this, you're going to get two values, plus one value and minus the other. And the value that you're going to be most interested in is you're going to get two answers. The first one's going to say t equals negative 259.71 seconds, and that's clearly no good because you can't have negative time. And the second one is going to be t equals 8.11 6 seconds. We'll round that to 8.17 seconds. And that's when the bottle is going to hit the water, after 8.17 seconds. If it's asking you for an exact value, leave it in radical form. If it's looking for an estimate, they might say to the nearest second, in which case I'd say t equals 8 seconds. Then you can find the exact value. So it's negative 120 minus the whole discriminant, square root of the discriminant, divided by 2a. The very last thing I'm going to show you, and I am running low on time, so I'm going to move quick through this, is what happens if I wanted to know how high, like how long will it take before it reaches, let's say, 50 feet. I would say negative 16t squared plus 120t plus 80 equals, well, let's say 48 feet rather. There's a reason for this. Well, because this is, I want to know how long is it going to take before it hits 48 feet. I'm just going to subtract the 48 on over. And I get negative 16t squared plus 120t plus 32 equals 0. And I'm going to do the same thing. X equals negative 120 plus or minus the square root of 120 squared, etc., etc. I'm actually not going to figure this out, although I keep continuing on. I'm not going to figure this out, but I will allow you to have the opportunity to finish it. Yep, that's right. Anyway, so figure it out. See how long it takes before it gets to 48 feet. Once again, you can use your graphing calculator for these as well, but I like to be able to do it out by hand. All right, I hope you enjoyed. Thanks.